In this video, we're going to look at systems of linear equations that are underdetermined or overdetermined. And we're going to use the Gauss-Jordan approach again. So we're going to use a matrix and set up our system, and we have 2x minus 5y plus z is equal to negative 9. So we have 2, negative 5, 1, and negative 9. And x plus 4y minus 6z is equal to 2. So 1, 4, negative 6, and 2. And we have 3x minus 4y minus 2z is equal to negative 10. So 3, negative 4, negative 2, and negative 10. And now we're going to use our row operations to solve this. So the first thing that I'm going to do, remember we need to get a 1 in the upper left corner. And instead of dividing the whole row by 2, I'm going to switch row 1 and row 2. So I'm going to say row 1 and row 2 switch. So my first step is to write row 2 where row 1 is, and row 1 where row 2 was. And then row 3 stays the same. And now we want to get zeros where the 2 and the 3 are, using row 1 as our pivot row. So we're going to have negative 2 times row 1 plus row 2. And we're going to put that into row 2. And then we're going to have negative 3 times row 1 plus row 3. And we're going to put that into row 3. So the first row stays the same. And now, negative 2 times 1 is negative 2, plus 2 is 0. Negative 2 times 4 is negative 8, minus 5 is negative 13. And then, negative 2 times negative 6 is 12, plus 1 is 13. Negative 2 times 2 is negative 4, minus 9 is negative 13. And then we have negative 3 times row 1, so negative 3 times 1 plus 3 is 0. Negative 3 times 4 is negative 12, minus 4 is negative 16. Negative 3 times negative 6 is 18, minus 2 is 16. And negative 3 times 2 is negative 6, minus 10 is negative 16. So now we need to get a 1 in our center. So we're going to do negative 1 over 13 times row 2, and we're going to put it back into row 2. So row 1 doesn't change. Row 2, we're going to multiply everything by negative 1 over 13. So we're going to have 0, 1, negative 1, and 1. And then row 3 stays the same. And now we're going to use row 2 as our pivot row. And we're going to try and create a 0 where this negative 16 is underneath our 1. So we're going to have 16 times row 2 plus row 3. And we're going to put that back in row 3. So we get row 1 staying the same. Row 2 stays the same. And now in row 3, we're going to multiply row 2 times 16 and add it to 3. So 16 times 0 is 0 plus 0, still gives us 0. 16 times 1 is 16 minus 16 is 0. And negative 1 times 16 is negative 16 plus 16 is 0. And 1 times 16 is 16 minus 16 is 0. So now we've got all zeros across the bottom. So now we're going to have infinite solutions, so we're going to need to involve a parameter. So we're going to say that z is equal to t. And now we want to write what we have remaining here. So if we read across row 1, we have x plus 4y minus 6z is equal to 2. And we also have y minus z is equal to 1. Now in our final answer, we don't want any x, y's, and z's in our answer. So we're going to substitute t in for z. So in this bottom equation where I have y minus z is equal to 1, I'm going to substitute t in for z, and I'm going to solve for y. So y is equal to t plus 1. So now we know z is equal to t, y is equal to t plus 1, and now I'm going to plug my y and my z into that first equation. So I have x plus 4 times y, which is t plus 1, minus 6 times t is equal to 2. And now I'm going to solve for x. So I have x plus 4t plus 4 minus 6t is equal to 2. And then I get x minus 2t because I have 4t minus 6t, and then plus 4 is equal to 2. And now I'm going to move everything but the x to the right side. So I have x is equal to 2t minus 2. So now my final answer is going to be x, y, z is equal to 2t minus 2, t plus 1, and t. So if we take a t value and plug it in for t, we can get the other values for the solution. And that's how we solve systems of linear equations that are underdetermined or overdetermined.